Welcome. First question, who has seen my talk yesterday? Okay, yeah, that's good. So because I'm going to make the same lame jokes as yesterday, and so you guys, you just laugh a little bit, and the other people, you laugh really. Um, so my name is Chris. I work for Twitter. You guys might, the people who have seen my talk yesterday, you probably think, oh, he's even wearing the same clothes, which is kind of true, but I'm wearing a different hat. That's very important. Um, So I live in Hawaii, as the flag here on my hat shows, and I work for Twitter. And the first question is, who has a Twitter account in here? That's a good turnout. Everyone else, please create one right now, because I'm asking you to tweet about this talk. And if you do, please add that hashtag, because Twitter has a small VM team of 4 people, and there are 3 GC engineers, and there's 1 compiler guy, and that's me. So I'm touring around and I'm talking about Graal and compilers and stuff, and it's great that so many people here in France come to my talks, because it's a very specific topic and not a lot of people are interested in it. So why am I doing this talk and all the other ones I'm doing? The main reason why I'm doing this is because I want you to try Graal. And the reasons I want you to try it is, number one, if you've seen my talk yesterday, you could potentially save money by running your business on Graal. The other is that I would like to get Graal to become a more mature compiler, and for that we need to throw different code at it, right? So yesterday I was talking about the bugs that we found when we started running Twitter services on Graal, and so it's all the code out in the wild that makes a compiler a mature compiler. If you run specjvb for the millionth time, nothing changes, but you want that shitty code that you guys run in production, you want that to throw at the compiler. So fix bugs and also improve Graal, because if you see more code patterns and then you see, oh, we should improve this, or if you're comparing it even, I don't know, you guys, you're running your stuff on C2 and then you run it on Graal and you say, oh, it's actually slower, that's good, right? Because we want to find these issues and we want to improve Graal. So this is why I'm doing all this. And so when I gave my other presentations, and then usually people come up to me and ask me, okay, so is it safe to use, right? Because it's an experimental compiler. So does your data center burn down if you run it? No, it does not, because ours are still up and running. How do I use it, right? And then where do I get it? Very important questions if you want to try it. So the latter two, well, the first I just answered, no, it does not burn down your data center. The latter two we are going to answer today. And then sometimes when people actually try it, they usually send me emails later and they say they're complaining of the benchmark numbers, and they usually say, well, Graal really sucks. And that's because they don't understand that it has different properties than the existing JIT compilers. And so this talk is exactly about this. I want you to tell why it's different, and I want you to tell what to look out for when you try it yourself. You'll probably have your, I don't know, maybe you have a benchmark suite or have your favorite benchmark that you run all the time, and then you have to know some things. Okay, so we're talking about this. If you want to know more about the money-saving part and you haven't seen my talk yesterday, that's the talk. There's a bunch of YouTube videos. I think they recorded it yesterday too, so you can laugh about the jokes one more time. So what is Graal? It's a Java virtual machine just-in-time compiler. Who knows what a just-in-time compiler is? Okay, that's good. So it's very short. It's taking Java bytecode and translates it into native code, and so that your application is running faster, and it does that during runtime. It's not like a C or C++ compiler doing it statically before you run it. It does it while you run. That's why it's just in time, okay? Okay, so Graal is actively developed by Oracle Labs. You might have seen the announcement they did 2 days ago, I think, with the Graal VM and all this. So they are really working on this right now. There's an official OpenJDK project. It's called Graal. Then the code lives on GitHub. We go into that later a little bit. It uses JVM CI, so I talked about this yesterday. It's the compiler interface that we added to Hotspot so you can run Graal, and then it's written in Java. And if you take away one thing from this talk, it should be that it's written in Java. And this is very, very important for this talk, because this is the major difference between Graal and the other JIT compilers. The other JIT compilers, C1 and C2, in Hotspot, are written in C++. C++ behaves very differently than Java does because it's ahead of time compiled, it allocates memory differently than Java does, and so on and so on. So we are going to talk about this. Good. Where do I get it? So in JDK9, we added ahead of time compilation, and ahead of time compilation, the implementation in OpenJDK uses Graal to compile native code. So if you have JDK9, there's a restriction, but I'm kind of skipping over this because in JDK10, which is now the latest and official version, they've added Graal officially in a way. So you can already use it in 9, but only on Linux x64, and on 10 you can use it on Windows, Mac, and but only 64-bit, not 32-bit. So there's CHEP 3.17, and in the JDK 10, it's included. So you have it. So okay, now this talk is very different than all the other talks I've ever given, because usually my talks are just slideware, right? I throw some numbers at you and say, this is great. This talk, I do a lot of demos, and I decided to do this talk very differently because I like it to be exciting, and I like to live on the edge. So I've not prepared anything, so what we're doing right now, I'm an Oracle Developer Champion, and so they give me free access to Oracle Cloud. So what we are doing is we are firing up an Oracle Cloud instance from scratch, completely empty. There's nothing installed in that thing, not even Java. And so we're doing this here on stage. And the people here promised me that Wi-Fi will work. We'll see. I like to do it with a wired connection because then I know it's probably working. So we'll see. Okay. So also, because I have to type a lot and I have to talk a lot at the same time, and we have to wait for things to load and stuff, there might be some awkward pauses, and they will be really awkward. So we'll see. Okay. Why is that coming up? That didn't come up earlier. Okay. So we're going to create a new compute instance. That's the Oracle Cloud thingy. I don't know if anyone is using that or has seen it before. Over Ethernet, it loads faster. I'm just saying. Okay. So here we go. So we create a compute instance here, and we call this one Devoxx France. And we create it in Frankfurt because it's the closest one. We use Oracle Linux 7.4. Then we use this virtual machine that has 4 CPUs, 4 cores. And then we need some SSH key here, and that's it. Okay, so now we create this instance. And now it's provisioning, and I hope this will go fast. We're waiting for this public IP address down here. And then, how's the font size? It's probably a little small for in the back, huh? Can you see that? Can you see what I'm typing? Good, good eyes. Excellent. Okay, here we go. So we grab this IP address. It's still provisioning, as you can see. So once it's done, I can't log in right now, obviously. So it's provisioning it, and then it says it's running, but then it has to image it first, and then it has to boot it up, blah, blah, blah. So this will take a little bit, and we have to wait for that. In the meantime, I'm going back here, and I'm talking about myself a little bit. So, as I said, my name is Chris. I work for Twitter. I used to work at different companies. I already said all this yesterday, but I'll just repeat it. I forgot 2 things yesterday that I didn't mention. I'm the Lava 1 organizer. So we had a conference in Hawaii this year in January. I don't know how the weather is in January here, but over there it was really good. Then, very important, I have 2,046 Vine loops. Who misses Vine? I do. No one misses Vine? He does, yeah, that's great. So I'm working on JVMs for a long time, over 13, 14 years. Most of the time, well, actually all the time, I've worked on compilers. And I used to work on a different JVM implementation back in the day, and we were using GNU GlassPath, and we all went to FOSDEM and were drinking beer. This is how this all started. And then some microsystems open sourced Java, and they showed up and said, oh, yeah, you guys are cool. And we said, yeah, you're cool too. And then at some point, I started working for them. And I was part of the Hotspot compiler team. And most of the time, I worked on C2, a little bit of C1 as well, but mostly C2. Did a lot of bug fixing in the beginning, and so on and so on. So the 3 biggest features that I worked on, besides fixing bugs and smaller improvements, were JSR 292. I don't know what Remy was talking about early in here because I didn't understand. I can't speak French. So I know him from the JSR 292 days. He was very, I'll skip that. So John Rose and I were basically working on the implementation for Invoke Dynamics, so we added this to the VM. John did a lot of the API work, like the Java API. I did most of the compiler work and a little bit of the interpreter work because we had to port it to different platforms and all that stuff for the interpreter. So yeah, if it doesn't work, you could technically blame me. I'd like to say that other people touched it after me and they broke it, but so that was the biggest one, I think. Then I've added, or me and other people, we've added JVM CI, the Java level JVM compile interface, into JDK 9. So you have it since JDK 9, and that means a compiler that is using that Java interface like Graal is. There's only one compiler out there today, and that's Graal. You can just plug it in and then use it, turn it on with flags. We'll see that later, and then you're just running on it. And then I did ahead of time compilation as well. I briefly mentioned it earlier. So it's using Graal, and you can compile Java class files down to a shared library, and then Hotspot picks it up automatically. And now I'm working at the Twitter VM team, and it's amazing. I love it. It's good. Let's see where we are here. Can I log in? Yes, I can. I was talking long enough. That's good. Here, logging in here too. And so I'm typing a lot. There might be a lot of typos because typing in front of a lot of people is always very, So this thing is empty, as I told you, right? There's no Java installed, nothing. So what we have to do first, we have to install Git because we need that later. And then we also need a JDK. No, not CHEP, JDK. We want a JDK 10. So we download this guy here. And here we go. The problem is always, oops, that was the wrong window. The problem is always, so this is a cloud instance in Frankfurt. And the servers where the JDK lives, they're in the US, so the download is always freakishly slow, which is so annoying. So we have to wait more than a minute for this to download. Very awkward, long pause. So we just wait for that Git thing to install, and then I'm downloading something else on the side as well. But this is just what we have to wait for. When I started thinking about doing this talk, when I see talks where people do a lot of demos, they usually do it on their laptops. Lately, maybe they do it in the cloud. But I'm always wondering, okay, how many hours did they spend that this demo actually works, right? All the setting up and environment variables and fixing a little thing here and there. So I thought, this talk should be for you to see what you need to run on Graal. So it's everything I do today, that's what you have to do as well. There's nothing, there's no cheating going on. Good. Look, 6 seconds. Amazing. And then what we also need, oops, we are downloading, go away. We're downloading the Scarlet of Capo benchmark because we're using this later for a bunch of things. And that server is somewhere in Europe because it's much faster. Here we go. Okay, got that. So we are unzipping that OpenJDK thing. Here we go. JDK 10, latest thing. We're going to set Java home. And we're going to set the path because we're going to use it a million times. Here we go. And we do the same thing over here. And I'm having 2 terminals because we are going to compare C2 and Graal later. And very good. Also, oh no, that was a mistake. What was the mistake? Yes, that was the mistake. Here we go. So we should have Java now. If I could type, there we go. Very good. Then Is there anything else I have to do? Yes. We are setting an environment variable. It's called Java Tools Options. Here we go. And we are going to use, because since JDK 9, G1 is the default GC. So, but we are looking at GC output later, and G1, the heuristics of G1, we don't really want that. We want a GC that is straightforward. So we're just using parallel GC, and also the parallel GC, and also the logging output is easier to understand. So we are also setting a pretty small heap size, just 512 megs, and that's so we can see when GCs are happening, and that's important later to understand what Graal is doing. And we're setting the maximum size and the start size at the same, and we do this to kind of have a level playing field for both C2 and Graal, because Graal, since it's Java, it's like the allocation profile is slightly different, and so the heap expansion would be different than with C2. But if we set the start size the same as the maximum size, we don't have that, so both kind of allocate the same amount and collect at the same time. Okay, good. Then we are taking this and also use it over here, but on top of it, we're going to CHEP 243, which was JVM CI that I was talking earlier about, and we scroll all the way to the bottom, and it tells us how to enable JVM CI and how to use a JVM CI compiler. So JVM CI itself is still an experimental feature, so you have to unlock them with this flag, and then you say, oh, enable JVM CI, which just enables the interface so that someone can access it. It does not automatically enable the compiler, and then you have to tell it, oh, please use the JVM CI compiler, and that's basically replacing C2 with Graal. Okay, so we do that over here, and then we say java-version, and we see, okay, we are picking up these things, and that's it. So let me quickly go back to my slides. What's next, actually? Kind of lost track a little bit. Yeah, okay, good. So we have all this stuff, and let me go back to the slides for now. No, I want to show you something else first, right? So here, so since 9, we all know there are modules, right? And so there's a command line option. It's called list modules, and there are like 75 modules, if I remember correctly. And there's a module called JDK AOT, and that's the AOT code, basically, that I was talking about earlier. And then there's another flag called describe module. And if we describe JDK AOT, we see what packages it contains and which other modules it requires, right? And it requires two things, and one is this one. It's called jdk.internal.vm.ci. That's JVM CI. That's the compiler interface. That module contains the Java code of the compiler interface. And then there's another module here, this one, jdk.internal.vm.compiler, and this one's Graal. It's just a module that contains Graal code. So if you have a JDK, if we list all these modules and we say jdk.internal.vm, and then there's the management package in there too, but if you have a JDK that has these two modules, you're fine. So everything after 10, you are fine anyway, but I'm telling you just to understand where the code lives and all this. So if you have this, you're good. So how do I use it? You get a JDK with Graal, that package, if you have it, perfect. We just verified that we do, so we're good. And then the only thing you have to do is turn it on. And I'm just showing it to you now. It's basically what I did here, right? I copied in these flags, and they turn it on. So if I run Java version, then it picks it up, and it turns it on. But we would like to see what's really going on, if it's really used. And there's a thing called print flags final. There we go. And we are looking for JVM CI. Oh yeah, sorry, I have to always do a version, because otherwise you get all this output you don't need. So there are a bunch of JVM CI command line flags, these like, what, 10? And then, for example, there's enable JVM CI, which is true because we turn it on, right? And then there's use JVM CI compiler, it's true because we turn it on. We're looking for this one, JVMCI print properties, and we do that, and then we see a long list of properties. And they are really properties because JVMCI, most of the part is written in Java and Graal is written in Java. So command line options to these two modules are Java properties, -D, and then you specify it. So there's a small list up here of JVMCI properties, and all the rest is stuff that you can tune in Graal. We're not doing this today because that would be a little much. We're looking for this one in a timer, and it prints out -D, this one, and it's a Java property, so you have to say equals true. This will print a little bit of logging while JVMCI is initialized and when it initializes Graal, but nothing's printed. So are we doing something wrong? No, we're not. But JVMCI and Graal are lazily initialized. So if people know what tiered compilation is? Okay, so I told you Hotspot has a C1 compiler and C2 compiler. And then the way you run your application is you load in the class files, and then you start interpreting it in the interpreter, and then at some point it gets hot and you compile it. But you compile it first on a lower tier with C1, because C1 is a compiler that produces code quicker than C2 does, or Graal does. But you want to go to native code as quickly as you can. And then in C1, you compile the code so that you you collect profiling information. And that profiling information is then later used in another tier, C2, tier 4, that's tier 4, to produce peak performance code. That's how it works. So you walk through the tiers to get to your peak performance code. How did I get there? I can't remember. Why did I mention tier compilation? I really don't know. But we'll see in a minute. So I think that's why. So if we do print compilation here, we see all the methods that are being compiled by doing a -version. So -version executes a little bit of Java code, but it's not a lot. And the third column in here is the tier level, the tier compilation level. And tier 0, you don't really see 0 yet as a 0 here, but it's something else. 0 would be the interpreter. Like tier 1, 2, 3 are C1 levels, and there are different compilation types, and it depends on how much profiling they do. And then tier 4 would be the top tier C2 or Graal, okay? There are no tier 4 compilations here because the code does not get hot enough. So we don't schedule a compilation with Graal, so it's never being initialized. So what we have to do, we have to run a little bit more. And so for that, we use the Scala da Capo benchmark suite that I just downloaded, and we do a -L, which just lists. Let me do the same thing over here, because I'm always saying this, and then people don't know what I'm talking about. It just prints out all the benchmarks it has, right? A list of the benchmarks it has. If we do this over here with Graal, you see, oh, yeah, there's something happening. So it's initializing something. It's doing this Hotspot JVMCI runtime, doing stuff, but it's not really finishing. And the reason for that is that the execution of just printing out the benchmarks exits sooner than the JVMCI initialization ends. So we have to run a little bit more to see what's really going on. And we're doing a small run of Aurora. This one, much better. So we see all this output. We see JVMCI is being initialized, does a bunch of things, and then it's done. Took 84 milliseconds. Then there's this compiler configuration factor, which basically selects the compiler. But since there's only one, there's only Graal, it just selects it. We don't have to specify it. And then it initializes Hotspot Graal runtime, does a bunch of things there, initializes the backend for our CPU architecture, and then it gets cut off. And I think the reason it gets cut off is because the Capo benchmark harness redirects output into a file, I think. So, but this benchmark run down here, that was running Graal. So we can run the same benchmark over here, and we do size small, Aurora. Here we go, and that should take 4.3 seconds usually. How much is this? 4.4, 4.5, yeah. So, and over here it took 5.23-ish. Okay? So left C2, right Graal. So it's slightly slower, and we'll get to why it's slightly slower in a minute. All right. So, because we have to talk about bootstrapping. I mentioned this yesterday, and I promised that we're talking about bootstrapping today. And so bootstrapping is, I mentioned earlier, Graal is written in Java. So Graal running in your VM is just another Java application. And that means it loads Java classes, obviously. It has Java methods because it's written in Java. And then at some point, these methods need to be compiled as well, because you're running with it, and they get hot, and they will be compiled. And you want them to be compiled because you want Graal, the compiler, to be fast so it can compile your application. That's bootstrapping. So let's do a bootstrap demo. We can turn on bootstrapping explicitly. I don't suggest to do this because it's rarely necessary or useful to do it, but it's very useful for me now to show you what I'm talking about. So a Graal bootstrap, an explicit bootstrap, basically takes all the methods of java.lang.object, which are like 5 or so, that are not native, but they're very small, right? They have a little bit of code in them. So they're very small methods. All these methods get scheduled for compilation, and while Graal is compiling these very simple methods, it starts to get warm itself, and then it starts to compile itself. Okay? So we're doing this now, and it says bootstrapping JVM CI, and every dot is 100 compilations. Okay, this should take roughly 10 seconds. Here we go, 10 seconds. And you can see we compiled about 2,600 methods. Okay? So you must be thinking now, what's the guy talking about? I don't want to wait 10 seconds for my tiny little application to start up, or I don't want to add 10 seconds to my startup of whatever I do, right? Start up Eclipse or whatever, IDE, I don't know. That's true, but it's only because we're doing this explicitly. So what the explicit bootstrap does is, let me show you something else while I'm talking. We could turn off tiered compilation, because in the first case, we were compiling Graal with C1 as well, but if we turn off tiered compilation, we don't have C1, and so Graal has to compile itself. And this will take way longer. It takes 30 seconds. So you remember that benchmark case that I showed you? Like over here, I still have the old number of this one. It's like 4.5 seconds, right? And the other one was 5.2-ish. It's roughly a second, even less than that. And the reason for this is you usually, in your whatever, where you run your stuff on your bare metal machines or in your cloud container, you usually have more than one core. I think it's rare that you run something that just has one core, because if you would, anyone doing this, just having one core? Probably not. Because what you want is, you want a bunch of cores to do your GCs, right? And you have all the GC threads, and if you have just one core, these GCs would take very long. So what Hotspot, what the VM does, is it has a compilation queue, and it has a bunch of compilation threads as well. And if the cores are free, it's just using it, right? And so that's what's happening in that benchmark, right? So you see that one took 30 seconds, and we compiled almost 5,000 methods. That's just Graal, basically. But if you run it in an implicit bootstrap, just in the background, it kind of disappears in the noise, because you're running your application, and you're compiling your benchmark in that case, and then in the background on different threads, it's compiling Graal itself. So it was roughly a second, right? So that's not too bad, especially when you talk about, this one runs just 5 seconds. I don't think your application starts up in 5 seconds. It's probably much longer. And the characteristics of compilations, I don't know if you ever looked at it, but the majority of the compilations, depending on the size of your application, obviously, but the majority happen in the first 30 seconds to 1 minute, maybe 2 minutes if your application is really big. But then you're more or less done. There's a compilation every now and then a little bit later, but that doesn't really matter. And in the very beginning, when you start up your application, you don't use all the cores because your application is not ready even to do work or accept requests or whatever it has to do. So it usually starts up. That's like Twitter services work, right? We run all microservices, they start up. Then you have to connect to other microservices, and then most of the time there's some loop in there so that the service warms itself a little bit up. That takes time. Once you're done with that and your application actually is ready to receive requests, all the compilations are done anyway, right? Okay, good. Going back. I'm skipping this one because this talk usually takes an hour, so I kind of just have to skip a little. So we saw that a bootstrap compiles a lot of methods, and all these methods are Graal methods, so additional stuff that needs to be done. It's roughly between 2,500 and 5,000, depending on how much work you do. And then you could do it up front, which I don't think you need to, but most of the time it's just on demand during your runtime when Graal compiles your application, your benchmark, whatnot, and then it just compiles itself when it gets hot. And we skipped that last line for now. Okay, so since we talked about Bootstrap, which is very important, we have to talk about Java heap usage. And Graal is, who remembers? Exactly, it's written in Java. So that means that all the memory it allocates comes from the Java heap. That's the biggest differentiator between C2 and Graal. Because C2 is C++, it does memory allocation with malloc on the native C heap, and Graal does it on the Java heap. Very important if you do benchmarking and you look at GC numbers or anything like this, you have to remember, oh, Graal is actually written in Java, so it allocates memory from the Java heap. So compiling your application will use Java heap memory. In the default setup, the tiered compilation setup where you run with C1 and Graal, Graal itself, if you don't change anything, Graal itself will only be compiled with C1. And the reason for this is because there's not too much difference if you compile Graal with Graal itself. Yeah, the throughput would be a little better, but what you want is for Graal to be up as quickly as possible so that it can actually compile your application. That's what you want. And C2's throughput is so quick that if this setup, it compiles Graal very, very quickly. And that's what we want. So if you don't really have to tweak that. That's how we use it at Twitter. So we don't do anything. We don't AOT compile Graal because we can't, because we are still on Java 8. And we don't change that. We just let C1 compile Graal every time we start up our thousands of instances of whatever service. No problem. Okay, let's do a Java heap demo. And let's look at what's going on. So we're going to use this guy again. Let me delete this one. And then we turn on GC logging and we run this one, yes, but we run 3 iterations of that guy. So Aurora is a very compute-intense benchmark, and so it allocates a little bit of memory, but not too much. All these GCs that you see here are forced GCs with system.gc, and so after the first warm-up, you see, oh, we had about 39 megabytes in the heap, and we collected down to like 1. So it's not allocating a lot of memory. And you see there is no GC happening in the actual benchmark runs. There's one warm-up 1, warm-up 2, and that's the actual third run. If we do the same thing over here, let's copy this guy, and run this with Graal, we see, oh yeah, there's GC stuff happening. And the reason for this is because Graal is compiling the benchmark. And so you see in the first iteration, this one, yeah, there's a bunch of stuff going on, and we collect from 130 megs down to 9. So we're allocating quite a bit of memory. But that's normal. In the left case with C2, we're allocating the same amount of memory. We just don't see it on the Java heap because it's allocated on the native malloc heap. In a cloud world, apparently, I still remember how long was that ago? Not too long ago, 9, 10 years when people said, oh, memory is free. Yeah, that's gone. Memory is not free anymore. It's super expensive. So your cloud instances, you usually buy by memory and then by CPUs. And if you get a, I'm just pulling numbers out of thin air. If you get a cloud instance that has 1 gigabyte of memory, okay, that's your memory. If you can't give 1 gigabyte to your Java heap, because then C2 couldn't do its work in the native memory, right? So you're using the memory anyway in your cloud instance. It's different where you use it. I'd like to think of it as if you run with Graal, it's more obvious to you what's actually going on and how much memory is being allocated. You can also think of it as, sure, this might not always be the case, but if you run with Graal, you could give your JVM more memory because you're not really compiling a lot on the native heap. And then later, when you're done compiling, you have the memory on your Java heap, and your application can use it. Might be an advantage. Who knows? So as you can see, in warm-up 2, we only had 1 more collection. And then in warm-up 3, there was no collection anymore. So at this time, and we are just, and it's actually, if you can see, it ran 3.9 seconds, and over here 4.2-ish. So Graal is actually executing the benchmark quicker than C2. So the performance is better. And there's no GC happening here anymore, and we are into, what was that? How much was it? 5 and 4. So we're kind of 10, 12 seconds into the run, and we're done compiling. So there's no compilation going on anymore. Good. Going back here, how much time do I have left? 8 minutes. Good. Graal uses Java heap memory. There is currently no heap isolation yet. The problem that could happen is if Graal uses memory, like everyone, as I said, the cloud world, right, 1 gigabyte of memory, you give your VM as much memory as you can, and then you tune your heap size to exactly how much you need, right, how much your application needs plus 1 megabyte more, because maybe. So that's how everyone does it. We do it like that too. So the problem that could happen if suddenly later in your run, when your application's fully up and accepting requests and working, it could be that a method gets compiled, and it could use several tens of megabytes or even hundreds of megabytes to do this, depending on how big it is. That could result in out-of-memory error. And the problem is that you don't know where the out-of-memory error will show up. It could show up in the compiler, on a compiler thread in Graal. Then it would be fine, because Graal would catch that error and say, OK, I can't do this compilation, whatever. But if it could also potentially show up in your application, if for some reason you do an allocation right now and you get the out-of-memory error, then it brings your application down. That's the only downside of the current state of affairs. But I also have to say, this has happened 0 times for us. And we are running tens of thousands of instances every day for 9 months now, and it never happened. Good. As I talked about earlier, most memory usage is during startup. Most Graal memory usage is during startup, because all the compilations happen at the very beginning when there's usually enough memory available because your application is not fully up yet. And then, yeah, memory is used anyway, either malloc or Java heap. So I have 6 minutes left, and I don't think I can do this. Yeah, well, this is the last talk in this room, I was told. Maybe we can go over a little bit. I would like to show you this. I'm doing 2 more things. I want to show you how to use the bleeding edge of Graal. You just download it from GitHub and compile it yourself and run with it. Because I see a lot of compiler engineers in this room, and you want to work on it. So we do that, and then later I show you a benchmark where you can see what Graal can do for you. OK. Build Graal demo, that's where we are. OK. So what we want, we go to GitHub. And you've seen this on Twitter in the last 2 days many, many times, Oracle Graal. So we grab that, we clone that one over here. So we say git clone, and then it got pretty big, so I'm just cloning a depth of 1, because otherwise we're waiting too long. All right, so we got that. And then we need something that's called mx, and it's a script that Graal is using to pretty much do everything. It's like a build system they built themselves. It's a freakishly huge Python. It's ridiculous. I told them many, many times I hate this shit and we have to remove it, but they didn't do it. So anyway, I have to live with it. So we clone that. It's like 10,000 lines long or something. It's ridiculous. Okay, MX. So we put MX on the path. And here we go. And then we go to Graal. There are a bunch of things in here, from the announcement. It's a little confusing, Graal VM and Graal, right? Graal VM is the whole thing. When I say Graal, I'm only talking about the JIT compiler, okay? Because it's called Graal. So that's the compiler, and then there is Substrate VM. You might have heard of this. There's Truffle in here. You might have heard of that. But what we want is the compiler. And so MX, it's picking up that thing. We are unsetting this for now to reduce the noise. And then we just build it, MX build. That's all we have to do. And it's picking up our JDK 10 from our Java home environment variable. It's downloading a bunch of dependencies it needs, and it's building it. This build will fail, which is fine. And the reason why it's failing is because it's building some support for Truffle, and it's using libffi, and that's a native library, and so it needs GCC. And you remember our cloud container didn't even have Java or Git installed, so it doesn't have GCC installed. I could install it, but it would take forever. So it can fail, it's fine. The only thing we need is a modular jar file. And I don't think we got that yet. There's sometimes a weird race condition going on with that build failure, so I have to build it maybe 2 or 3 times until we have our modular jar file. And then we can use that modular jar file and replace the existing module in the JDK with the new one. Okay, good. Let's see. We should be done pretty soon. Awkward pause. Everyone, but we all like compilation output, right? It's cool. Okay, here we go. Archiving Graal, that's exactly what we need. And it compiles a bunch of tests. We don't, here, building Java module. That's exactly what we want. Okay. So there's now a file in here. It's called jdk.internal.vm.compiler, not surprising, .jar. That's the modular jar file. Okay. So if we go here into this directory and then say mx vm-version, which doesn't work because I didn't set that up. Okay, here we go. Going back, compiler, and so it prints it out twice because it tries to figure something out, but that's basically, we just run -version and it prints out the version. We can add a -v here in front, which is a little bit verbose, and then what we want to see is this is the command line that's being used. And in that command line, you can see it's using upgrade module path with that modular jar file. So now we are running with Graal that we just compiled, like completely the latest bleeding edge stuff you can do. So if we run, let me do this again. If we run this Scala da Capo benchmark that we were running earlier, and I forgot over here, we want to log class loading, and we grep for Graal. I only have 1 minute left, that's not a lot. So these classes are being loaded from this JRT file system. That's the internal module file system that the JDK uses, and it loads it from that module, right? That's the module that it's shipped with the JDK. If we run that same command with mxvm, like this, you see that all these classes are being picked up from this file. Okay, so we are actually using the modular jar file we just built. So just for fun, and every time I do this, no, wait, I have to get rid of this. I'm running this benchmark, and every time I hope it's faster than it was before. It never is, but you can see it works. There you go, 5.8, whatever. So that's how you can do it. So you download Graal from GitHub. You can import it in your favorite IDE, IntelliJ, Eclipse, you name it, NetBeans for the hardcore people. And then you can, play around, add new optimization, whatever, fix a bug, whatever. Just that's how you can run on the latest version. Good. Now in my last, oh no, I'm over. Good. But we do that. So we set this again, but we use a slightly bigger. Okay, it's not really important, but for the sake of, I'm skipping the production demo. We don't have time for this, but we're doing the Scala demo. We're using a 2 GB of heap, because otherwise we get too many GCs, and then you can't see what I'm talking about. So we are running, we log GC again, and we're running the Scala, the benchmark called Factory. And we do 2 iterations is usually enough. I like to do 3, but 2 is enough. That's fine. And over here, we set the same, and then we use 2 GB here, and here as well. And then over here, just for fun of it, because we're waiting for it to complete, you can go to benchmarks here, and then you can see, oh, it's Factory here. It's a toolkit for deployable probabilistic modeling to extract topics, uses latent trait, whatever. So it's doing stuff. And this is, frankly, I have to say this benchmark, it's written in Scala, and like pretty much all of Twitter's microservices. And this is the benchmark that shows the best improvement that I've ever seen. So I picked the best one, obviously, for my talk. But so we're seeing, okay, this was the first warm-up iteration, and so we're waiting for this one. And we started about at GC 50, and we ended at 87, so that's 88. That's 38 GCs, so roughly 40 GCs that it has to do to complete all this. And you see it creeps up a little, but it's like 750 megs, and then it's collecting down to 74. If we run that same thing over here with Graal, and it took 27 seconds runtime. So with Graal, you remember, okay, Graal, running with Graal means we have to compile the application or the benchmark with Graal, so that means a little more memory allocation and so on and so on. So we're waiting for this warm-up to be done. You can already see the warm-up was done in 19 seconds, which is already much better than a 27. And now we're waiting for the real first run. And we're doing an awkward pause for a minute. That's not a minute, it's less. So this should be done now. So it took 19 seconds to do this versus 27, which is a lot, right? That's 20% or even more. What you also can see is we did 40 GCs over here, right? But we only did 20 here. And that's what I was talking about. If you saw my talk yesterday, with the Twitter service that I was trying, we got like only 2.5% less GCs. But this is exactly what Graal can do for you. If you have an application that does some memory allocation in a certain pattern, and Graal can inline more, and then its partial escape analysis can get fully to work, it can do this for you. It's like it reduced the GCs in half, which means if you care about latency or things like this is amazing, right? And then the runtime itself is also great. So this is the best benchmark I can show you. I'm very, very sure that you won't see this for your application in production, but that's what Graal can do for you. Okay, I'm 4 minutes over, but I'm done. And my summary is very simple, and it's just this. That's all I want you to do.